In this lesson, we'll look at how to solve absolute value equations. So what the bars do, the absolute value bars, all they do is turn a number positive. For example, if the absolute value of x equals 7, then there are two possible values for x. Because remember, what the bars do is turn the number positive. If I have a negative 7 and do its absolute value, that'll make it positive 7. And if I have a positive 7 and leave it positive, it'll give me positive 7. So x could be either 7 or negative 7, because either way the absolute value is 7. So absolute value equations can have two answers. And we're going to now try to solve one that's a little more complicated. Absolute value of 3x plus 5 equals 29. Now, what this is saying is that what's inside the bars, once you turn it positive, equals 29. And that means that what's inside the bars could either add up to positive 29 or negative 29. So we will write two equations. And we will solve them both. We'll subtract 5 from both sides. That'll give us 3x equals 24. And now we'll divide both sides by 3. And so x equals 8. And for this other one, we do the same steps. We subtract 5 from both sides. Negative 29 minus 5 is negative 34. And we divide both sides by 3. So our second solution is negative 34 over 3. And we just wrap those up in a nice little package and put them in curly braces. Our two answers are 8 and negative 34 over 3. Fortunately for us, absolute value equations cannot give you false solutions the way radical equations did. So we will not necessarily have to check these unless we just want to check our work. Okay, now I want to show you one thing that's a place where a lot of people make a mistake, and that is people get confused on where to change the sign. And I want you to notice that in both equations I copied down exactly what was in the bars. You do not change the signs on the left side of the equation. It's the right side. It's either positive 29 or negative 29 in this case. It's the right side that changes sign, never what was in the bars. That always stays exactly the same. One other thing you need to know about absolute value equations is that you can't write your two separate equations until you have the bars all isolated. So now let's look at one where there's other things around the bars before you start. And we just need to always remember to isolate the bars first. So this minus 10 and times 5 both have to go. Let's start by adding 10 to both sides. And so 10 plus 5 is 15. And now let's get rid of this 5 multiplier. So we will want to divide the 5 away. And if I divide the left side by 5, I just have the bars now. And the right side divided by 5 gives us 3. So a lot of students ask me, do we have to divide the 5 away, or could we just distribute it? And probably sometimes you could get away with distributing, but I wouldn't get too comfortable with it, because if you distribute a negative, you're really going to be messed up, and it's just a safer thing to divide the 5 away. I really would never distribute through absolute value bars. So if we take the bars now equal to 3, that means what's inside the bars has to be either positive 3 or negative 3. So here's where I get my two equations. What's inside the bars is either 3, or what's inside the bars is negative 3. Alright, now let's solve. If we subtract 1 on both sides and divide both sides by negative 4, the first solution is negative 2 over negative 4, which gives us negative 1/2. And the second solution, subtract 1 from both sides, divide both sides by negative 4. Negative 4 divided by negative 4 is positive 1. So our two solutions are negative 1/2 and positive 1. Now, we are going to check negative 1/2 and 1, not because we have to, but just because we know that it's wise to check your work sometimes, and it's good to know how. So I'm going to plug negative 1/2 back into our original equation and make sure that it's correct. So I will copy the original equation over, except I will copy negative 1/2 in the place of x. So now to simplify, negative 4 times negative 1/2 is going to make positive 2. And 1 plus 2 is 3. And 5 times 3 is 15. And 15 minus 10 is in fact 5, so that solution is correct. And now let's check the other solution, which was positive 1. So same thing, we copy the original equation, but with the 1 in place of the variable. And then 4 times 1 is 4, and 1 minus 4 will be negative 3. Now the absolute value of negative 3 is positive 3. And 5 times positive 3 will be 15. And 15 minus 10 is in fact 5. So that solution is good as well. And so we know that these two solutions now are correct. We'll just look at two more together. Here is absolute value of 2x plus 1 plus 3 equals 3. And of course I need to isolate the bars. So we'll do minus 3 on both sides. And now I'm ready to write my two equations, but because I have a 0 over here, I really can only write one equation. There's no such thing as positive 0 and negative 0. So when I take the bars off, I just get 2x plus 1 equals 0. And when I solve, I get x equals negative 1/2, and that's the only solution we get here. So this is the only time when you'll get one solution for your absolute value equation. And then for this example, 7 times the absolute value of 3x plus 2 equals 16. Let's always remember to isolate the bars first. So we'll do minus 2 on both sides. And we'll divide both sides by 7. And now what's inside the bars could equal positive 2, or what's inside the bars could equal negative 2. If we divide both sides by 3, there are our two solutions, positive 2/3 and negative 2/3.